In this video, we're going to look at sets and Venn diagrams, specifically if your exam board is AQA. If your exam board is Edexcel, then you may want to check out my previous video instead. Imagine your school's maths department had 10 teachers. Some of these teachers were male, and some of them were female. Some of them also wear glasses, and some of them do not. This would mean we could group them into the following categories: male teachers who wear glasses, male teachers who do not wear glasses, female teachers who wear glasses, and female teachers who do not wear glasses. We could also represent each of these groups in a Venn diagram. If we took a Venn diagram which looks like this, and we say the left circle is going to be for male teachers, this would mean that all of the teachers that we place inside this circle must be male. And then if we say the right circle is for teachers who wear glasses, any of the teachers that go in this circle must wear glasses. This also means that any of the teachers in this overlapping section here must be both male teachers and teachers who wear glasses. So we can start with those. We know there are 2 male teachers who also wear glasses, so they go in the middle. This section on the left-hand side is still in the circle for male teachers, but not inside the circle for those that wear glasses, so it must be male teachers who don't wear glasses. In a similar way, this right section here is for teachers that wear glasses, but it's not inside the circle that says male teachers. So we're looking for teachers that wear glasses that are not male teachers, which is these 4 teachers here. And then we're left with 2 more teachers that are not male and do not wear glasses, so it looks at first as though they can't go inside the diagram. Well, they don't go inside the circles, but they're still part of the diagram. What we do is draw a rectangle around all of the people like this, which we call the universal set. The universal set includes all of the things that could have been placed inside the diagram, and since these 2 teachers were part of the maths department, they need to be included in the diagram somewhere. We give the universal set this symbol here, which is a Greek letter xi. In your exam, you're more likely to encounter a Venn diagram where frequencies are used instead. So instead of these 2 people on the left-hand side, we just write the number 2. Instead of the 2 in the middle, we'd write 2. Instead of the 4 on the right, we'd write 4. And the 2 on the outside, we'd write 2. Let's have a look at our first example of an exam question on Venn diagrams. There are 32 students in a class. 27 students were present on Monday, 29 students were present on Tuesday, 26 students were present on both Monday and Tuesday. Then we're given a Venn diagram that looks like this, where the M represents students that were present on Monday and the T is for students that were present on Tuesday, and we need to fill the Venn diagram in. The first thing to look at is the 27 students that were present on Monday. This means there must be 27 students inside the Monday circle. A very common error that I see is writing 27 here. This would be students that were present on Monday but not Tuesday. It doesn't include this overlapping section here, which is the students that were present on both Monday and Tuesday. They were still present on Monday. So at the moment we can't do anything with this number 27. If we look at the next sentence, 29 students were present on Tuesday, which means this circle here needs to have a total of 29 students. Again, a really common error will be to write 29 here, but that also doesn't include this overlapping section in the middle. So what we want to do is look at the final sentence. 26 students were present on both Monday and Tuesday. That's this overlapping section in the middle, so we can be sure the number 26 goes in here. Now if we return to the previous sentences, 27 students were present on Monday means this whole circle here needs to be 27. We already have 26, so there's just one more to add in. So in this left section here, we just write the number 1. If we move to the next sentence, 29 students were present on Tuesday means this whole circle here needs to be 29. We have 26 already inside this circle, so we need 3 more. Now there's a total of 29 present on Tuesday. It might also feel like you've now finished the question, but if you add up all of the students we've assigned so far, 1 add 26 add 3, you end up with 30. But the question says there were 32 students, so there are 2 students still not in the diagram. Those students must not have been present on Monday or Tuesday, so they go down here. And that's the answer to this question. Let's try a second example. In this question it says 100 adults were asked if they use Facebook and Instagram. 12 of the adults said they use Facebook and Instagram. 45 of the adults said they only use Facebook, and 25 of the adults said they do not use any social media. And then we have this Venn diagram to fill in for those that use Facebook for F and those that use Instagram for I. So we know that 12 of them said they use Facebook and Instagram. That must be the overlapping section in the middle, so we can place 12 right in there. Then it says that 45 of the adults said they only use Facebook. Now the word only here is really important. If they only use Facebook, then they don't use Instagram. So we're just talking about the left-hand side of the Facebook circle, not the overlapping section in the middle. So it's not the whole Facebook circle that needs to make 45, this bit is just 45. If the word only wasn't in that sentence, then it would indeed be 45 for the whole Facebook circle. So one word can change the answer to a question. In the final sentence, we find that 25 of the adults do not use any social media. So they don't use Facebook, they don't use Instagram, so that means 25 goes down here. So we've got one section left to fill in. If we add up all of the people we've done so far, 45, 12, and 25, we get a total of 82. In the question, we were told that there were 100 adults, so if we subtract 82 from 100, we find there are 18 left over. So 18 must go in this final section here, which is those that only use Instagram. It's very common on AQA for them to combine fractions and percentages with Venn diagrams. Let's have a look at an example like this. 80 students went to Alton Towers. 60% of the students went on the ride Oblivion. 3/4 of the students went on the ride Nemesis. And 50% of the students went on both rides Oblivion and Nemesis. And we need to complete this Venn diagram here, where O is for those that rode Oblivion, and N is for those that rode Nemesis. For a question like this, I would try and work out all of the percentages and fractions first, and turn them into frequencies. So let's start with 60% of the students that went on the ride Oblivion. This means we need to find 60% of the 80 students mentioned in the question. To do this, I would find 10% first, by dividing 80 by 10, which is 8 students. Then to get 60%, we can multiply this by 6. 10% times 6 is 60%, and 8 times 6 is 48. So when it says 60% of the students went on the ride Oblivion, that's just saying 48 students went on the ride Oblivion. Then it says 3/4 of the students went on the ride Nemesis, so let's work out 3/4 of the students. To do 3/4 of 80, you first divide 80 by 4, which will give you 20. This is finding 1/4. To find 3/4, you multiply that by 3. So 20 multiplied by 3 is 60. So when it says 3/4 of the students went on Nemesis, that just means 60 students went on Nemesis. In the final sentence, it says 50% of the students went on both rides. To find 50% of 80, you can just do 80 divided by 2, which is 40. So 40 students went on both rides. Now that we have these as frequencies, we can complete the question like we did in the previous two examples. Let's start with the students that went on both rides. This is often the easiest way to start one of these questions. If you've been given that information, that goes in the middle. So we need to put 40 in the middle. So we've used this information. Then 60 of those students went on Nemesis, which means the whole Nemesis circle needs to add up to 60. At the moment we have 40 in there, so if we subtract 40 from 60, we're left with 20. So this section here must be 20. So we've used this 60. Let's go back and look at the students that went on Oblivion, which is 48 students, which means this whole circle here needs to add up to 48. There are 40 in that circle already, so if we do 48 subtract 40, we're left with 8. So 8 must go in this section here. So now that we've used that 48, don't forget to work out how many didn't go on either of the rides. We know from the question that there were 80 students, and if you add up all of the ones we have so far, 8 plus 40 plus 20, you end up with 68. If you subtract this from 80, you're left with 12. So there must be 12 outside of the circles, but still inside the universal set. The next question we're going to look at appears straightforward, but can actually cause quite a headache. 50 students were asked if they like maths and science. 10 students dislike both subjects. 32 students said they like maths. 23 students said they like science. And we need to complete this Venn diagram here, where M is for those that like maths and S is for those that like science. Well, we've got 10 students that dislike both subjects, so they won't go inside the circles at all, they'll go in this outside section here. We then have 32 students liking maths, which means this whole circle here needs to add up to 32. But we don't have any other information, so we can't fill in those numbers yet. And we have the same problem with the 23 students that like science. This whole circle here needs to add up to 23, but we don't have any other information to help us with this. So it feels like we don't have enough information in the question to complete it, but we do. We're told there are 50 students in total. At the moment, we've got 10 students in the diagram, so if we subtract 10 from 50, there are 40 remaining. This means all of the numbers that go in these circles combined needs to make a total of 40. So if we draw it out like this, then the sum of all of the regions needs to make 40, but we know from this statement here that the left circle needs to make 32, and we know from this statement here that the right circle needs to make 23. If we add together the students that like maths and the students that like science, we get a total of 55 students. This seems like there are too many students, especially because we know that there must be a total of 40 across all of these regions. If we subtract the 40 students we need from this total of 55, we find we have 15 extra students. But there is a reason for this. Since we added together the students that like maths and the students that like science, we actually counted this region twice, since it's in both of those circles. This is made clear if we combine the diagrams. You can see that we end up counting this region twice. That means the region that we counted twice must account for those 15 students. So there must be a 15 in the overlap in the middle. Now that we have this information, we're able to complete the question. So if we place a 15 in the middle for those students that like maths and science, and then return to this statement here, 32 students like maths, we know this circle needs to make 32. So if we subtract 15 from 32, we find there are 17 students remaining, so that goes here. And for science, 23 students, so this circle needs to make 23, so if we subtract 15 from 23, we end up with 8. So 8 goes here. You may want to double check your answer here just by adding up all of the totals, and you will end up with 50 students. Sometimes an exam question may give you a completed Venn diagram and ask you some questions about it. In this question, we're told 100 students in a college were asked if they study maths or physics. And here's the completed Venn diagram. One of the students is going to be selected at random, and we need to answer the following questions. Work out the probability that this student studies maths. If we add up the two numbers inside the maths circle, we get 35 plus 30, which is 65. This means 65 of the students studied maths. Since the question asks us for a probability, we need to write this as a fraction of all of the students. In the question, we're told there are 100 students, so it will be 65 out of 100. What about if it said the probability that the student studies physics? Well, we do the same idea for the physics circle. If we add up these two numbers here, 30 plus 25 is 55, so the probability will be 55 out of the total students 100. Now, what if the question said the probability that the student studies maths and physics? Well, that's the students in the overlapping section in the middle, so it's just 30 out of 100. And what if it said the probability that the student does not study either maths or physics? So that would be these 10 students on the outside here. So the probability is 10 out of 100. What if the question said the probability the student studies maths but not physics? So we're looking for students inside the maths circle that are not inside the physics circle. That's these 35 students here. So the probability would be 35 out of 100. And finally, what if it said the probability they study maths or physics or both? So this is any of the students that study at least one of those subjects, which is all of the students inside both of the circles. So if we add all of these together, 35, 30, and 25, we end up with a total of 90. So the probability is 90 over 100. Next, we're going to take a look at some set notation. Here we have a Venn diagram for two sets A and B. The set A is anything inside the A circle, and the set B is just anything inside the B circle. But what about this set here? A with this symbol and B. This symbol here is known as an intersection symbol, and we sometimes say it aloud as the word AND. So this could be A and B. So we're looking for everything that's inside both of the A circles and the B circles, which is the overlapping section here in the middle. So A intersection B, or A and B, is the overlapping section of the Venn diagram shaded here. You also need to know about this one. This symbol here is known as the union symbol, and we sometimes say it aloud as OR. This is anything that's in the A circle or the B circle, which is the entirety of both of those circles. We also need to know about this set. If we take a set like A, but then put a little dash above it like this is known as the complement of A, and we can say it aloud as not A. So we're looking for everything that's not inside the A circle. It's almost like the opposite. If the A circle is here, then anything not in the A circle is here. So the red region here is not A. It works in exactly the same for set B. B with a dash is the complement of B, which we say aloud as not B. So this is the B circle, so we want everything that's not in the B circle, which is this red region here. Let's summarize the sets we've just looked at. First of all, we have the set A, which is the A circle. Then we have set not A, which is everything not in the A circle. We also have set B, which is the B circle, and set not B, which is everything not inside the B circle. We also had the intersection of A and B, so A and B, which is the overlapping section in the middle, and we had the union of A and B, which is A or B, which is anything inside either of those circles. AQA also describes this last one as A or B or both. Let's have a look at how we can use this in some exam questions. Here we're told about a Venn diagram which represents 40 items, and we're asked to work out P brackets A, which means the probability of A. Since we're doing the probability of A, we're looking for the probability that we select an item that's inside the A set. Inside the A circle here we have 10 and 3, which makes a total of 13 items. So the probability that we'd select one from here is 13 out of the total, which we are told in the question is 40 items. So it's 13 out of 40. If we were asked to work out the probability of B, we'd do the same idea but for the B circle. So in the B circle we have 3 and 20, which makes a total of 23. So the probability will be 23 out of the total 40 items. But what about this probability? The probability of A and B. If you remember from before, this was the overlapping section in the middle. Here we have 3 items, so the probability is 3 over 40. You also need to be able to do this probability, the union, which was everything inside both of the circles. So we need all of these here, which is 10 add 3 add 20, which is 33. So the probability will be 33 over 40. You could also be asked to find this probability, the probability of A dash, which we learned was not A. So let's look for everything that's not inside the A circle, which would be the 20 and the 7. 20 plus 7 is 27, so the probability is 27 over 40. In a similar way, we can do the probability of not B. So everything not inside the B circle, which is the 10 and the 7, 10 add 7 is 17, so it's 17 over 40. For the remainder of the video, we're going to look at some more difficult sets. Whilst these could appear on the foundation paper, if you look at past papers, they don't ever seem to have been assessed. So if you do the foundation tier, you're welcome to stick around for the end of the video, but also it may not be too likely to appear. So far, we've met the following sets. We're going to take a closer look at the intersection and union sets. Let's make a second copy of each of these sets. And instead of keeping them exactly the same, we're going to put brackets around them and then put the dash, which we said means not. So this set on the top right is not the intersection, or not A and B. When we did the set not A earlier, I mentioned how it was sort of the opposite of A. So if we take the actual intersection, which we know looks like this, the set not A and B must be the opposite of this. So we need to unshade that part, but shade in everything else. It works in the same idea with not the union. So the union of A and B looks like this, and if we do not this, it's everything else. So we unshade that part and shade everything else, and it looks like this. So you've got 2 new sets now, not the intersection and not the union. You could also be asked to shade a set that looks like this, which is not A and B. If you're given a set like this, my advice would be to imagine the set separately first. The set not A, you should already know, it's everything not in the A circle, and the set B is just the B circle. Remember, this symbol here means AND. So we're looking for everything that's in the set not A and also in the set B. So we're looking for the regions that are common to both of these diagrams. Let's split our Venn diagram into 4 regions. We have 1, 2, 3, 4. We're going to check each of these regions one at a time to see if it appears in both of the diagrams. If it appears in both of them, then it's in not A, and it's also in B. So that's a region that we want. Let's start with region number 1. Region number 1 is not in this diagram, and is not in this diagram either, so we don't want that one. Region number 2 is not in this diagram, but it is in this diagram, but that's still not good enough because we want it to be in both. Region 3, however, is in this diagram and this diagram, so it will make an appearance in our set not A and B, since it's in both of them. And finally, region 4, which is the outside, it is in this set, but it's not in this set, so we don't need it. So there's only actually one region that's in both of these sets, not A and the set B. So there's only actually one region that's in both sets. Region 3 is in not A and it's in B, in which case that's the region we shade. So the set not A and B looks like this. In a similar way, the set A and not B would be the opposite of this, so just this left section here in the set A. AQA also describes these sets in the following way. The one on the left could be everything that's not in A and also in set B. And the one on the right is everything in A that is also not in B. And now let's take a look at another set that you need to know. The set looks like this time, and it's not A union B. Remember, this union symbol here is the word or. So we're looking for anything that's in this set, not A, or this set, B. We'll consider those four regions again. Now, when you're looking for a union, you're not looking for something that's in both of those sets. You're looking for anything that appears in either of those sets. So as long as it appears once, we're going to count it in our set. If we look at region 1, it's not in this one, and it's not in this one. So it will not appear in our answer. If we look at region 2, it's not in this one, but it is in this one. So we will include it in the answer. So let's shade in region 2. Region 3 is in this one, and it's in this one, so that will definitely be included in the answer, so we shade in region 3. And region 4 is in this one, but not in this one. But that doesn't matter, because it's in at least one of them, so we will include it in the answer. So we actually include all of the regions in this, apart from region 1. Another way that you could think of doing the union of two different sets is just overlapping those two sets, and then seeing the resulting regions that are shaded. You can see this matches our diagram perfectly. Those of you with a keen eye might notice that this region here is slightly darker than the other ones. That's because I've overlapped two of these diagrams here, but this region was actually in both of them, which is also another way of thinking about what the intersection of those sets means. Remember when we did the intersection a moment ago, we were looking for regions that were in both sets. So if we just choose this region here, that was the intersection. So you could think of the union as being any of the regions that are in either of those sets, and the intersection as the regions that are in both of the sets. Now you also need to be able to flip this union around, so rather than doing not A union B, doing A union not B, which would be the opposite diagram, so it will look like this. AQA describes this left set as the union of not A and B, and the right set as the union of A and not B. So let's summarize all of these new, more difficult sets we've looked at. We have these two sets, of course, but we also looked at the intersection of not A and B, and the intersection of A and not B. And then we also had not the intersection, and not the union. This now completes the list of all of the sets that you're required to know for the AQA specification. In an exam question, you may be given one of these sets and asked to shade it in, or you could be given a diagram that's already shaded and be asked which set it corresponds to. Thank you for watching this video, I hope you found it useful. Check out the one I think you should watch next, subscribe so you don't miss out on future videos, and why not go and try the exam questions in this video's description.